So hello everyone, this is lecture 29 for the classical physics. In the last lecture we were discussing some questions about Lagrangian and Hamiltonian. So let's discuss three more questions, then we'll see a new topic, that is canonical transformation. So here is the question. The Hamiltonian for a particle is given h equal to p square by 2m plus k qt, where q and p are generalized coordinate momentum, t is time and k is constant. Initial conditions are given, q is 0, p is 0 at time equal to 0, and there is a relation qt is proportional to t alpha. Then we need to find a value of alpha. So first we need to find this relation, then we can find the value of alpha. So I already discussed this kind of questions where we find this kind of relation between qt and pt. So you will do the same procedure here also. First you will do q dot, that will be del h by del p, that will give you p by m from here. Now you know what is p dot, means to find the q and t relation you need to remove p from here, because here you have dq by dt, that will give you dq into p by m multiplied dt. And now to remove this, means integrate this dq, you need to give value of p in place of means in place of p you need to find it in terms of q. So how you can do that? So you will find this p dot also, then this will give you del h by del q, means using this relation, second equation of motion for the Hamiltonian, this will give you dp over dt. Now you have dp over dt, you have dq over dt. So using these two relations, dp over dq can be found it. Then you have a relation between p and q, you will substitute in place of p in terms of q, then you can solve this equation, that will give you your answer. Okay, means you will get some equation qt is proportional to t to the power something, that will be 3 or 4 something, so alpha will be that answer. So you can see my last lecture, you have their question, this kind of questions, you can solve this. Lagrangian of a free relativistic particle in 1D of mass m is given. Lagrangian is given minus m under root 1 minus x dot square, where x dot is dx by dt. If such a particle is acted by a constant force in the direction of its motion, the phase space trajectory obtained from the corresponding Hamiltonian are. So you know what is phase space trajectory, we already discussed when we started classical physics. So it was a relation between p and x, so a plot which is between momentum and the position, that gives you phase space trajectory. So you need to find a relation between p and x, so that's how you can find that if that curve be ellipse, cycloid or hyperbola or anything. Okay, so how we will proceed? See, it's a free particle, and to find the relation between p and x we need to find the Hamiltonian. Why? Because Hamiltonian here, this motion is conducted or supported by the constant force, so that means the energy, means Hamiltonian will be constant of motion, so that will give you your energy, and energy you can find F into x. So you can just equate energy equal to Fx, and energy is Hamiltonian, so total energy is Hamiltonian. So that's how you need to first find the Hamiltonian, then you can equate that to find the value of p and x, means to find this graph. So that's how we'll proceed. So first Lagrangian is given, first we need to find the Hamiltonian. So potential for a free particle is 0, and we know this relation, momentum is nothing but del L by del x dot. So use this relation to find this is plus sign, and you will get p is equal to mx dot divided by under root 1 minus x dot square. Now to find the Hamiltonian you need to find x dot in terms of p. So use this relation, this will go this side, just simplify this, you will get x dot equal to p over under root p square plus m square. Now you have x dot. To find the Hamiltonian, what is that you will use, that is x dot p. So x dot p minus Lagrangian will give you Hamiltonian. So x dot is this, multiply p will give you p square divided by this. So this will be your Hamiltonian, p square by under root p square plus m square, and minus, and this Lagrangian was in minus, that's why you have plus here. So m under root 1 minus, that was in place of x dot, we write it this. So we get our Hamiltonian as this, p square plus m square divided by under root p square plus m square. This will give you under root p square plus m square, because this is a square of this. Now this is your Hamiltonian, and this is constant of motion because you have a free particle. So this will be equal to total energy, and total energy is nothing but force multiplied displacement, because this is conducted by this force, as I already told you. So Fx will be equated to this. Now here you can find the relation between p and x by solving this. How? This will go this side, it will give you f square, x square is this side. Now you have this relation. Now take this m square this side. Now you have x square minus p square equal to m square. Divide the whole equation by m square, you will get this relation. Now you can see this relation, this is a relation of hyperbola. Okay, so your answer will be hyperbola, the phase space trajectory will be hyperbola. Let's see one more question. If the Hamiltonian of a system is given by this, p square exponential minus nu t 2m half m omega square x square exponential nu t, where x and p are generalized coordinates, then L is given by. So this is a simple question. You need to find the Lagrangian. So you will use the relations x dot equal del h by del p will give you this. Then you will find p in terms of x dot, p will be this. Now use the relation L equal to px dot minus h. So in place of p you will write this value and Hamiltonian from here. Now this will give you this. In place of here also you will use in place of p, that is mx dot divided by exponential minus nu t. Now you solve this, you will get again this value with half value. So 1 minus half will give you again half mx dot square, and this exponential nu t can be taken common from the whole terms. This will be as it is, and this is exponential nu t. So this will be your answer. Okay, this will be your Lagrangian. So that's how you can solve this. So let's move forward to our new topic, that is canonical transformation. So before understanding canonical transformation, first we need to understand canonical conjugate pairs. So you many times comes into the questions that they are conjugate pair and all. So what is the meaning of conjugate pair? So a pair qi pi, these are generalized coordinates, is called canonical conjugate pair only if this pair satisfies Hamilton's equation of motion simultaneously. So if this pair at the same time both will satisfy these equations, we know these are the equation of motion for the Hamiltonian, then we call that pair as canonically conjugate pair. Why? This is like you have x and px in the Cartesian coordinate system, and by knowing the position and the momentum or velocity, you can describe the complete journey of a particle or the future. In the classical mechanics, you can determine all of things with these two things. Now, same in the generalized coordinates, if you know these qi and pi for a particular coordinate, then you can describe whole the complete motion. Means these two equations describe the complete equation of motions. So there you have in terms of x px, here you have in terms of q and p. So that's why if this pair satisfy Hamilton equation of motion simultaneously, then we call them canonically conjugate pair. So always remember them. Now what is the meaning of canonical transformation? So if these are the coordinates for a particular Hamiltonian of a system. Now let's see if we change these coordinates to a different coordinates, means because you are free to take any generalized coordinates. Okay, so one can take one pair, another one can take another pair, that other pair is also satisfy this equation, and this pair is also satisfy this equation. Then to convert this first pair into second pair and both pairs satisfy this equation of motion, that conversion is called the canonical transformation. Now first system has Hamiltonian H and its variables are qi pi, we call them old variables. Now we convert the system into the another system or the new variables, that is qi pi, which also satisfy these conditions, means they are also canonically conjugate pairs. Now if you have new generalized coordinate, then your Hamiltonian will again be new something, it will change. So in new variable, this is your Hamiltonian, this is your qi pi, new variables, and these are your order variables. Now they also satisfy these conditions, and they also satisfy these conditions for the Hamiltonian. Now conversion of this from this is called the canonical transformation, and by which function you convert them, these to these, is called a generating function. Now let's see some theory. In order to understand the time evolution of the system, time evolution, what is the meaning of time evolution? Means how our particle will go in future. Okay, means what is its trajectory and all. So all information is given by these things, these equations, and that is called a time evolution. Means how with time these coordinates are changing. So in order to understand the time evolution of the system, the transformation from older variables in the newer variables called canonical transformation, as I already told you. This canonical transformation always take place according to some rules. Means this will take place only according to some rules, only then they are going to satisfy these equations. That connects older variable to the new variable, and this rule is called a generating function. So this function will play the role to convert these into these. The older and newer variables can connect each other in 4 ways. Now we have the 4 generating functions you need to remember, which can convert this to this. Okay, that is the main thing here for the exam point of view. The older and new variable can connect each other in 4 ways. So there are 4 type of generating functions. So why it is 4? Let's see why it is only 4 equations or 4 generating functions. So in this Hamiltonian, we know there are two equation of motion associated with it. Means with each variable there are 2 equations. So if you have n, means if you have n variables, these, then they will also be n. Then you have 2n equation of motions. Okay, now in the new variable also, if you convert them qi to capital Qi and pi to capital Pi, they will also have the nn. Okay, means they will also have the 2n, means maximum equation of motion of the new coordinates will be 2n. Okay, so here also 2n, here also 2n. So why it is 2n coming? It is coming from here. For each variable you have these two equations, so that's how, means n for this, n for this. So that's how you get 2n here, and here also it is 2n max, means because they can be less also, but they can't be more than 2n. So why it is? Because you have only two independent coordinates here. Okay, generalized coordinates. So by taking only two independent coordinates, now you have four things here: qi, pi, capital Qi, pi. Now it's a simple permutation combination of maths. You have four things, and you need to make pairs. Okay, and one should be from here and one should be from here, definitely. Okay, then how many pairs you can make? That will be four. One, you will take first this, then this with this with this, then this one, this with this, and this with this. So that's how you'll get four pairs only conversion, and that's how you'll get only four generating functions. Now the functions can be given by these formulas. Now each function carries one older variable, one new variable, and other two can be written in the depending form, because they will be depending. There will be only two independent variables. Okay, now let's see how. So you need to remember these formulas, they are very important. So I will tell you how to remember. See, first it is older variable is qi, capital Qi. Then you need to find pi and capital Pi, means small pi and capital Pi. Just from here you know these two, other two will be depending. So pi will be del fi divided by, it will be, if it is small then here will be small, if it is capital here will be capital. Now forget these negative signs, I will tell you how to remember them. Just here remember this: if it is pi then del fi divided by del q1, and here also this pi equal to del, it is 1 here. So minus, forget this minus 1, del f1 divided by del q1. Same, if it is pi then here will be qi, and these are the, if here it is qi then here will be pi, and here it is capital Pi, here will be qi. So for qi here will be pi. This is just reverse thing. So you can see in all these relations you have the same thing: here qi, here pi, qi. And if these are independent, then if this is independent pi, then small qi will be depending. Okay, and you can find this relation. Now what is the sign thing? So remember, for the f2 and f3, f2 mein, in the f2 both will be positive, in f3 both will be negative. Remember this thing, then you can find out everything. So for f3 both will be negative, and for f2 both will be positive. And this every coordinate for qi, small qi, will be negative. So for this it is negative, so for this also it will be negative. And for pi also, capital Pi, means for small qi and capital Pi, they will be negative. So this will be negative here. Now capital Pi is here, so it will be negative. Here capital Pi, here it will be negative. So that's how you can remember. Means for f2 will be positive, for f3 all negative, and small qi negative, and capital Pi is negative. So wherever you have small qi, that will be negative, and where you are having capital Pi, that will be negative. So that's how you can remember these four equations or generating functions. So just remember these, they are very important thing. Okay, so now you can convert older variables to the new variables. Now what is the use of this? Means why we are doing, means why we are converting this coordinate system to this coordinate system. What is the benefit we are getting? Here canonical transformation is required if one finds to solve the problem. Why canonical transformation is required? So if one finds to solve the problem difficult in older variables, so he or she want to move a new set of variables in which it will be easy to solve the problem. One chooses new variables in such a way that number of cyclic coordinates is greater in newer variables. As a result of larger number of cyclic, see what is they said here, means in the older system there will be a less number of cyclic coordinates as compared to new one. So when you have cyclic coordinates, then that will reduce your number of equations. Means this was 2n max, so this will reduce this number, and if you have less number of equations, then that will be easy to solve. So maybe in the new variables we will have less number of equations to solve. So that's why we are converting. As a result of larger number of cyclic coordinates, number of independent variables are reduced. Now lesser number of equations or motions are required to solve to understand the dynamics of the system. So see, let me give you an example. This is your older Hamiltonian that is given in terms of, you have 4, means 4 for this, 4 for this. So you have 8 coordinates and t. So you have 8 equation of motion here, because 1 is associated with each one. So you will have 8 equations here: q1 dot, q2 dot, q3 dot, q4 dot, then p1 dot, p2 dot, p3 dot, p4 dot. Now you have 4. Okay, 8 equations, and these are canonical conjugates. Okay, Qi and Pi. Now see, in the new system we are getting capital Qi and capital Pi, and there we are getting Q2 and Q3 are cyclic. Means here nothing is cyclic. What is the meaning of cyclic? Means that coordinate will not be present in the equation. So we already discussed the cyclic coordinates. Now in the new system Q2 and Q3 are cyclic. So the P2 and P3 will also not be present in the equation if they are cyclic. Then we only have Q1, Q4, P1, P4, T. Now see, you have only 4 equations. Every equation is associated with each variable, independent variable, because these are two cyclic, so they will be giving 0. So they will be constant of motion. So here you will have only these 4 equations. Now in the new system you have 4 equations, in the older one you have 8 equations. So which is easy to solve. So this will be your easy to solve. Okay. So that's why you need the new variables. Okay, that's why you apply the canonical transformation. Now for the P2, P3 they will be came out to be constant. That's why we don't have there. Okay. So this is your new Hamiltonian that will be in this form. Now see, these are your 4 equations for these 4, and here you have the 8 equations like this. So that's how you did this. Now how you find this new Hamiltonian? There is a simple relation between the old and the new Hamiltonian. K will be, this is a new Hamiltonian K, equal to h plus del f by delta t. So this f is any one you are using, means any one of the genetic function you are using. Just apply it here and you will find the new Hamiltonian. So this was just the introduction of this. Now we will see a lot number of questions based on all these things, so you will have everything clear about the canonical transformation and what kind of questions are asked in the paper. Okay, so I hope you understand this concept. So that's it for today. Thank you everyone.